lesson. So let's go over number 8 from the homework. There we go. AT is 80, LE is 76, and ER is 134. So we're going to use the fact that inscribed angles are half the arc. So we're going to start halving a lot of things. To get angle A, we'll take angle 76 and divide by 2. So that one's 38. To get angle E, we can take 80 and divide by 2. So that one's 40. To get angle ETR, we can take 134 and divide by 2. 67. To find angle L is opening up to 80. So half of 80 is 40. Angle E is also opening up to 80, so it's 40. Angle R is also opening up to 80, so it's 40. I was finding things I didn't need to find, huh? Angle LAE is half of 76, so it's 38. And angle EAR is half of 134, so it's 67. So all you're doing over and over again is finding the arc. I know those numbers are so small. Finding the arc and dividing by 2. Follow the rays of that angle. Follow them with your fingers to find out what arc it's intercepting. Find the measure of that arc and divide by 2. Because when it gets really messy, like a spider web, you're going to want to follow it to see exactly what arc it opens up to. All right, so that was not today's, sorry. The name of today's lesson is, well, it doesn't really have a name. Angles of chords, secants, tangents. It's kind of a lot of angles. And we're going to look at 7 different types of angles. Oh my goodness. Ready? So, angle 1, that's an inscribed angle. It equals its arc. Its arc is 42 degrees. Angle 1 is 42 degrees. Angle 2, that's an inscribed angle. It's half of its arc. So if its arc is 62 degrees, then the angle is 31 degrees. This one we got to at the very, very end of yesterday. It's not called an inscribed angle, but you treat it like an inscribed angle. So if this angle is 40, that arc is 40, sorry, you cut it in half, and that's 20. So because the vertex is on the circle and the vertex is on the circle, you're looking at where the vertex is, you get to just take the arc and divide by 2, even though it's not called an inscribed angle. It's a chord meaning a tangent, not the radius meaning a tangent, a chord meaning a tangent. We don't know how to do 4, 5, 6, and 7, so we're going to learn how to do those right now, okay? Theorem number 1 of the day. If an angle its vertex is not the center and its vertex is not on the circle, it's floating somewhere in the interior of the circle, then you take the 2 arcs that it intercepts, you add them up, and you divide by 2. So it's called finding the average. You're finding the average of the arcs that it intercepts. So let's say you're looking for angle 4. You take this arc, you take this arc, you add them up and divide by 2, and that's the measure of angle 4. It's also the measure of this angle because those are vertical angles. So you're finding really both of those angles at the same time by looking at what arcs both of those angles open up to. Okay? So if an angle is inside a circle, you add the arcs and divide by 2. Inside, add the arcs and divide by 2. So we're going to try a couple real quick. Measure of arc AB is 46. Measure of arc DC is 90. Find X and Y. Hussein, go ahead and tell us what X is, and Brandon, tell us what Y is. I was frozen. Okay, I'm back. 46 plus 90 divided by 2. Awesome job. 68. And Brandon, what is the measure of angle Y? Very good. What are those called? Anyone just tell me what they're called? Old news, vocab word. Who's going to get it? Supplementary. I was thinking linear pair. No, they're not vertical angles. 112, 68. They're supplementary, but I was thinking they're called a linear pair. Okay? All right, let's try another one. Give you a minute to think about that one. Pair of 78. So 180 minus 78 is 102. So this angle is 102. That angle, it's 102 on both sides. That angle is the one opening up to these arcs. So I know if I add my arcs and divide by 2, I'm going to get that angle, 102, not 78. 78 is not the angle that's opening up to those arcs. So if I add my arcs and divide by 2, I should get 102. So we work backwards. X plus 106 equals 204. And then subtract 106. And X is 98. Let me show you one more way real quick. The way that I really saw this the first time was I know if I add arc A and B, if I add them up and divide by 2, I get 78. So if I add them up and divide by 2, I get 78. So I know A plus B has got to equal 78 doubled, right? I don't know what A is, and I don't know what B is, but I know together that this plus this equals 156, because when you add them and divide by 2, you get 78. So the way I did it was I know that they equal 156, so I found this arc, 156 plus 108, and I subtracted that arc from 360 to find X. 2 good ways, only one answer, 98. All right, what do we do when the angle is not inside, when the vertex is outside the circle? The good news is you just do the opposite. You subtract the arcs and divide by 2. You subtract the arcs and divide by 2. So you're always going to do the larger arc minus the smaller arc divided by 2. So if this arc is 100 and this arc is 40, then the measure of that angle would be 100 minus 40 divided by 2. So it would be a 30-degree angle. Subtract the arcs and divide by 2. Whereas the other one is add the arcs and divide by 2. Cool thing is, 3 situations, only 1 rule. You've got 2 secants. Oh, subtract the arcs and divide by 2. Arc minus arc. You've got a secant and a tangent. Oh, subtract the arcs and divide by 2. You've got 2 tangents. Oh, don't worry. Subtract the arcs and divide by 2. All of those have one thing in common. The vertex is outside the circle. So outside subtract, inside add. All of those situations, subtract the arc and divide by 2. So let's try this one real quick. To get this angle, you subtract the arcs and divide by 2. So to get that angle, you subtract arc minus arc, and divide by 2. So this is a work backwards problem. So 150 minus x is 80. And then we would do 150 minus 80. We would trade places with these two guys. And that would be our x. I hope that's okay with everyone. 70. 70-degree arc. We were looking for the arc and not the angle, and that's why we had to work backwards. Oh, I doubled it. The opposite of dividing by 2 is multiplying by 2. So I was getting rid of that 2 in the denominator. Thank you for asking. All right, we're almost done, guys. Hang in there. Oh, this one's way too easy. Way too easy. This one should have come first. Subtract the arcs and divide by 2. 100 divided by 2. Yep. 50. Subtract the arcs and divide by 2. 158 minus 58 is 100, divided by 2 is 50. Last problem, I'm going to let you take your quiz. Subtract the arcs and divide by 2. But wait a minute. We don't know that arc. But we do know that when a chord goes through the center of a circle, that chord is the diameter. So we can find that arc by knowing that that's a semicircle, 180 minus 38. And now you can subtract your arcs and divide by 2. You may start your quiz. You need a little bit more explaining on the x plus y divided by 2. Okay. So when you've got a circle and you've got an angle, like angle 1, inside the circle, you take the measure of its intercepted arc, so this could be 30, and this might be 120, and you simply add the arcs and divide by 2. The only way we can make it difficult is if we're making you find the arc and not the angle, and you would need to work backwards. But either way, that one's 75 and that one's 75 because they're vertical angles. So in this next example, we want to find the angle. That's good. We're not going to have to work backwards. We're finding the angle and not the arc. But we've got 2 tangent lines. And so they only gave us one arc because they only needed to give us one arc. So we know to find measure x, we subtract the arcs and divide by 2, but we don't know that major arc. So we need to use the knowledge that a circle has 360 degrees. So 360 minus 100 would be 260 degrees. So now we can subtract our arcs and divide by 2 to get ourselves that 80-degree angle. Next problem. So be careful in this problem, the vertex is not inside the circle, it's not in the interior, it's not in the exterior, sorry. It is on the circle. So always be looking for where that vertex is. So we're going to use the rule of an inscribed angle. An inscribed angle is half its arc. So we're going to find the missing arc, 360 minus 200. We're going to find the missing arc, and then we're simply going to take the arc and divide it by 2, because that's the rule for the inscribed angle. So we've got another 80-degree angle. All right, here's a good problem. Find the value of x and y. So when I've got a problem like this, I just like to document every single thing I know on the picture. I don't try to find y right away. I don't try to find x right away. I start to just add whatever I know is true to my picture. So what things are true? Well, look at here. When a radius meets a tangent line, you get a right angle. So when a radius meets a tangent line, you get a right angle. So I know that angle is 90. Then I can use right triangles. And if this one's 29, then it's the complement of this other one. So I subtracted from 90, and I got that angle, 61. So now I can just find the linear pair of 61. 180 minus 61. So this angle is 119. And now I need to find y. So what I'm going to do to find y, I'm trying to think if this is the best way, but I still think that this is the best way. Oh, there's other ways, but let's do this way. I like this one. We know that this 61, to get that 61, you add that angle's arcs and divide by 2, and that gives you 61. So I'm adding the arcs, which are 40 and y. I'm adding them up, dividing by 2, and is getting me our 61 degrees. So when you're finding an arc, you're always working backwards. Every time you're finding an arc. When you're finding an angle, you're working forward, or you're just using the application of the formula. But we're working backwards. So the first thing we're going to do is get rid of this divide by 2. So we're going to multiply both sides of our equation by 2. So we get 122. And then the opposite of adding 40 is subtracting 40. So we would subtract 4D, 122 minus 40, 82. And now we have found x and y. Still more examples left. Woo, this is the lesson that never ends. All right, we talked really briefly about this yesterday. I didn't have time to go into great length about this, so I'm glad that this one showed up today. We learned a theorem that said when an angle is inscribed in a semicircle, it's a right angle. But what that theorem was really saying is that if an angle is opening up to a diameter, if it's opening up to a semicircle, that arc is 180. When you take 180 and you divide by 2, you get 90. And when you take 180, this one's opening up to the same thing. Look, oh, opening wide. It's the same thing. So when you take 180 and divide by 2, you've got 90 as well. So it's just saying when an angle is opening up to a diameter, it is a right angle. That's kind of a shortcut. If you want to find the arc, which is 180 every time, and divide it by 2 every time, you totally can. But when an angle is inscribed in a semicircle, it is a right angle. All right, we did make it through all of the examples for today.